Welcome, everyone, to the deep dive. I am incredibly enthusiastic to welcome you to today's exploration
Yeah, I'm super excited to be here.
because whether you are, a seasoned developer who has built 50 enterprise applications, or you're just someone who is fiercely curious about how large-scale digital experiences are actually constructed behind the scenes, this deep dive is entirely for you.
Absolutely. It really covers the whole spectrum.
Right. So if you think about it like this, when you look at a modern glowing city skyline at night, all you really see are the lights, right? You see the sweeping glass facades, the illuminated windows, the beautiful polished presentation.
Exactly. Yeah. You are just looking at the finished product, the
Yeah.
presentation layer, if you will.
Yeah.
Like the CSS, the front-end components, the final rendered HTML on the device.
But what you don't see, what is completely invisible to the person just walking down the street, is the massive, incredibly complex subterranean network that actually keeps that city alive and functioning.
Oh, for sure. The pipes, the grid.
Right. The high-pressure water mains, the sprawling power grids, the subway tunnels, the fiber optic cables routing data at the speed of light. And when we talk about modern digital experiences, the lightning-fast web apps, the seamless e-commerce sites, the global publishing platforms.
Usually just focus on that skyline.
Exactly. We look at the shiny Next.js components, but today our mission is to go underground. We are exploring the engine room of modern web development.
I love that analogy.
Thanks. So specifically, we are diving deep into the Contentstack developer ecosystem. We want to shortcut the learning curve of Contentstack's architecture, taking you from the very first API call all the way to deploying a fully automated composable application.
Which is quite a journey, honestly.
It is. And we have a massive stack of official documentation and Academy resources to distill for you today.
And, it requires a bit of a paradigm shift if you are used to legacy monolithic systems.
Oh, totally.
Because in those older systems, the database, the back-end logic, and the front-end HTML rendering
Right.
are all tightly coupled on a single server, right?
Yeah, it's all just one big block.
Exactly. So moving to a headless, API-first architecture fundamentally changes how you approach the structural design of your digital products.
Okay, let's unpack this. Because building a headless CMS isn't just about where the content lives, It's about how the content moves.
Right.
How it flows from a writer's brain into a highly structured database, through an approval state machine, out to a third-party translation service, back into the system, and finally out to a global network of servers to be rendered on your user's phone in milliseconds.
And that concept of movement and routing is really the ideal framework to keep in your head.
Yeah.
Content is no longer a static blob of text stored in a rigid page template. It is dynamic, it is modular, and it demands intelligent routing.
Well said.
And to achieve that routing at an enterprise scale, you have to establish the right foundational pipes first.
Absolutely. So before we can display content, before we secure it or automate it, we first need a pipeline to get data into the system efficiently. I mean, if you are migrating an enterprise application, you aren't going to ask a team of interns to manually copy and paste 10,000 records into a user interface, right?
God, no. That would be a nightmare.
A complete nightmare. So that brings us to the backend APIs. Specifically the Content Management API, or the CMA.
Right. And the distinction between the Content Management API and the Content Delivery API, the CDA, is really the absolute bedrock of a headless architecture.
It's crucial.
It is. They serve entirely divergent purposes and operate on completely different infrastructure layers.
Break that down for us.
Sure. So the Content Management API is a read and write REST interface. It is strictly your operational backend. It is how you programmatically create new entries, update specific fields, upload massive media assets, or mathematically define your content type schemas via JSON.
Meaning you are interacting directly with the core databases of the Contentstack infrastructure. It handles highly complex write operations, data validation, and logic execution.
Which means, and this is key, it is absolutely not designed to handle high-load front-end traffic.
Right.
Like if you build a web application and you configure your Next.js server to fetch articles to display to your users using the Content Management API, you're creating a massive architectural bottleneck.
Wait, because it's doing too much heavy lifting.
Exactly. When a user queries the CMA, they are hitting the central nervous system. If your application experiences a massive traffic spike, say, an article goes viral and your front end is slamming the CMA with thousands of read requests per second, you risk exhausting connection pools.
Oh, wow.
Yeah, and that ends up degrading the editing experience for your internal content teams who are actually trying to work in the CMS.
That makes total sense. So
Yeah.
the structural solution to that is the Content Delivery API.
Yes, that is your read-only endpoint.
And the CDA is backed by a highly optimized global content delivery network.
Yes, correct. When your application requests content for a user, the CDA serves that compiled JSON payload from an edge server located physically close to that specific user.
Which makes it insanely fast.
So fast. It is built to absorb millions of hits a second. It caches the payloads aggressively. And the beauty of the architecture is that Contentstack automatically purges that specific edge cache the exact millisecond you publish an update via the CMA.
Oh, that's huge.
Yeah, ensuring cache invalidation is handled for you automatically, which, as any developer knows, is usually one of the hardest parts of computer science.
Yeah, the old joke, right? Naming things and cache invalidation.
Exactly.
So rule 1 of headless architecture, CMA builds and manages the system, CDA serves and displays to the user.
Spot on.
And to interface with these APIs without having to write raw HTTP requests from scratch, Contentstack provides highly optimized SDKs available in JavaScript, .NET, and Java.
Or saves so much time.
Right, because instead of dealing with verbose fetch calls and header configurations, you just initialize a stack object in your code base, and you use semantic promise-based methods to query your data.
Yeah, it abstracts a lot of the boilerplate. And, because the Content Management API has the authority to overwrite your schemas or even delete your entire production database.
Which is terrifying.
Yeah, highly terrifying. So authentication is handled through a completely different mechanism than the delivery side.
Okay, so how does that work?
For the CMA, you generate management tokens.
Wow.
You configure these inside the Contentstack UI under Settings and Tokens. These are highly privileged read-write keys.
Whereas the delivery side uses delivery tokens, sometimes called access tokens, right?
Right. And those are strictly scoped to a specific environment, like staging or production. They only have permission to read published data.
So if a malicious actor scrapes your front-end code and finds a delivery token...
The worst they can do is read the public blog posts that are already live on your website.
Right, which isn't a security breach at all, really.
Exactly. But if they compromise your management token, your entire infrastructure is vulnerable.
So keeping management tokens strictly on your backend servers, safely injected as environment variables and never exposed to the client-side browser is basically non-negotiable.
100% non-negotiable.
Got it. So as you embark on building these backend integrations, I noticed the official documentation strongly points you toward using Postman.
Yes, they do.
Now, for you listening, you likely already use Postman to test your own backend routes, but the way Contentstack integrates with it is highly optimized. They provide official Postman collections and environment files hosted on GitHub.
Yeah, it's a great resource.
You import the collection, and it populates every available API call from creating an entry to updating a webhook.
And the environment variables in Postman are the real operational advantage here.
How so?
Well, you download the environment template, populate it with your specific API key, your management token, and the content type UID you are targeting. Because those variables are dynamically injected into the Postman collection's headers and URLs, you can test complex API interactions instantly.
But wait, I have to push back on this a bit. Why spend the time configuring all of those variables in the Postman UI?
What do you mean?
I mean, if you are a Node developer, you already have your code editor open. You already have the Contentstack JavaScript SDK installed via NPM. Why not just write a quick script to test the connection? It seems like downloading Postman files and mapping UI variables is adding an unnecessary layer of friction.
Ah, I see what you're saying. But the friction is intentional because it isolates the variables.
Isolate how?
Think about it like this. When you write a quick Node script to test a payload and it fails, the error surface area is massive.
Right.
Is there a syntax error in your JavaScript code? Did you misconfigure the SDK initialization? Did you format the nested JSON incorrectly? Or is the Contentstack API actually rejecting your specific request?
Oh, I see. You don't know where the failure point is.
Exactly. By utilizing the Postman collection, you isolate the network layer entirely. You prove, beyond a shadow of a doubt, that your API keys have the correct permissions, and your JSON payload perfectly matches the schema requirements of the database.
So you strip away the application logic to validate the infrastructure logic.
Precisely.
Okay, that actually makes a lot of sense. And the Academy resources highlight a highly practical exercise using Postman. They suggest running a simple get a single entry query against an existing piece of content.
Yeah, that's a great exercise.
The API returns a massive JSON object. You take that response, strip out the system-generated metadata things like the created at timestamp, the updated by user hash, and the internal version numbers, and you tweak the text fields.
Right.
You then use that modified JSON object as the exact payload for a create entry post request.
And what's fascinating here is how this JSON-based API-first approach completely transforms the concept of platform migrations.
Oh, let's talk about that.
So if you are migrating a legacy CMS that contains tens of thousands of articles, you don't manually enter that data.
Like you said earlier, no interns copying and pasting.
Right. You utilize the Contentstack CLI, the command line interface. You write a script that loops through your old SQL database, maps the legacy columns to the structured JSON schema you just validated in Postman, and uses the CLI to fire thousands of automated create entry requests to the CMA.
Wow.
Yeah, you can migrate an entire enterprise database in a matter of minutes, programmatically preserving the exact structure and relationships of your content.
That is incredibly powerful. But okay, so you've built the pipeline, you've imported the data, the engine room is full of highly valuable content. But the sheer power of the CMA and the CLI introduces an immediate operational threat, doesn't it?
It absolutely does.
Because you cannot have everyone in your organization holding the keys to the kingdom. If the pipeline is that fast, the damage a single mistake in script could cause is catastrophic.
Which introduces the cybersecurity concept of the principle of least privilege.
Okay, define that for us.
It is a fundamental security architecture doctrine that dictates a user, a program, or a process should only have the bare minimum privileges necessary to perform its intended function.
Nothing more, nothing less.
Exactly. And in the Contentstack ecosystem, this is enforced through a strict architecture of roles and permissions.
Right. Looking at the built-in roles, you have a solid foundation right out of the box. First, the admin, or super admin, possesses omnipotent access.
They can do everything.
Yeah, they create content, manage environments, configure webhooks, establish third-party integrations, and critically, they define the roles of other users.
Then you have the content manager.
Let's break that one down.
The content manager role provides vast control over the data itself. They can create, edit, and delete content across the entire system. But they are structurally prevented from accessing the administrative layer.
So they can't mess with the underlying plumbing.
Right. They cannot modify a webhook URL or alter the environment configurations that your front-end application relies on.
And then the developer role rounds out the built-in options. Developers obviously need to be able to create and modify content types. They need to alter the database schema.
Right. They need access to the API documentation and management tokens.
But a developer doesn't need to manage users. The role restricts them from user administration, meaning a rogue or compromised developer account cannot secretly escalate its own privileges to admin.
Exactly. Now, those built-in roles cover the broad strokes, but enterprise environments demand high granularity.
Definitely. I like to think of the CMS like a high-end restaurant.
Okay, I like where this is going.
So the admin is the owner of the restaurant. They sign the lease, they redesign the kitchen, they hire the staff. The content manager is the head chef.
Making the menus.
Right. They dictate the recipes, they manage the line cooks, they have absolute control over the food, which is our content. But the head chef cannot cancel the lease on the building or rewire the electrical system. Yeah. And the developer is the kitchen architect. They come in, they build the stoves, they route the gas lines, they optimize the layout of the prep stations, which represent our content types. But they don't hire the waiters, and they certainly don't cook the food.
It illustrates the separation of concerns perfectly. And when you need to constrain the line, cooks, the individual authors and editors, you implement custom roles.
Yes, let's talk about those.
You construct a custom role by meticulously selecting permissions grouped into 3 strict categories: content, publishing, and languages.
Okay, so in the content category, you restrict access down to the specific content type, right?
Yes.
So like a financial writer custom role might be granted read and write access to the quarterly earnings report content type, while a blog writer role cannot even see that the financial content type exists in the user interface.
Exactly. It declutters their workspace and secures sensitive data. Then you have the publishing category, which allows you to control the blast radius of human error regarding environments.
Blast radius, I love that term.
Yeah. For example, you can assign a junior editor the ability to publish their work to the staging environment so they can preview the content on a private URL. But you explicitly deny them the permission to publish to the production environment.
So they literally cannot push anything live to the public.
Exactly. And finally, the languages category is critical for global architectures.
Right, for localization.
Yep. If you have an external translation agency, you construct a role that grants them edit access strictly to the localized French and Spanish variations of your content entries.
But completely locking them out of the core English source material.
Exactly. By enforcing the principle of least privilege through these custom roles, you aren't just defending against malicious actors, you're defending against operational mistakes.
Which are way more common, honestly.
Oh, way more common. You structurally eliminate the possibility of a junior editor accidentally publishing half-finished draft content to your live, public-facing CDN.
All right, so the gatekeepers are established, the roles are defined. But content creation is inherently collaborative, right? I mean, if you have a writer, an editor, and a legal reviewer, how do they actually interact with a single piece of content without overwriting each other's work?
Well, the structural security we just discussed dictates what a user can do. The workflow feature dictates when they can do it.
Okay.
Workflow transforms the CMS from a simple data repository into a highly orchestrated state machine.
Which eliminates the dark ages of content collaboration. I mean, we all know the nightmare of emailing Microsoft Word documents back and forth.
Oh man, don't remind me.
You have a file named like homepage v2 final use this one .docs.
Yeah, and two people edit different versions of the file locally, and the reconciliation process is just chaotic.
It's awful, but Contentstack brings the entire editorial pipeline into the structural logic of the database.
Right. You implement a workflow by defining a sequence of linear stages. A standard enterprise workflow might begin with a draft stage, transition to an in-review stage, move to approved, and culminate in published.
And these workflow stages are mathematically mapped directly to the custom roles we just established, right?
Exactly.
So you configure the workflow logic so that only a user with the writer role has the authority to transition a specific piece of content from draft to in review.
Right.
And once the content enters the in review stage, the state changes. The writer is functionally locked out of making further edits.
Yes. Now, only a user with the editor role possesses the authority to interact with the entry.
Okay.
They can either reject it and regress the state back to draft with attached comments, or advance the state to approved.
It creates a fully auditable chain of custody. You have database-level logs of exactly who modified the content, the precise timestamp of the state transition, and the current lifecycle stage of the payload.
It's incredibly transparent, but the real architectural power here lies in publishing rules.
Ah, yes. The documentation details an exercise where you configure a rule named publish to production. Tell us about that.
So a publishing rule acts as a strict programmatic interceptor. You define a rule that explicitly states, the action of publishing to the production environment is strictly prohibited unless the workflow stage of the specific entry is actively set to approved.
So what does this all mean? It means even an admin, a user who holds omnipotent system privileges, cannot bypass the human editorial process.
Exactly.
If an admin attempts to force publish a draft article to production, the CMS interceptor triggers. The publish action is blocked and the system throws an error.
Right, because the content must satisfy the strict mathematical conditions of the workflow state before the API will distribute the payload to the CDN.
That is amazing. Workflow is really where the unpredictable human element is governed by the predictable technical system, guaranteeing organizational compliance.
And that guarantee is vital, especially in regulated industries. So the content safely navigates the workflow state machine, legal approves it, and finally, an authorized user executes the publish command. The CMA processes the request, and the payload is distributed to the CDA edge servers. The content is officially live.
Awesome.
But this introduces a massive architectural challenge in a decoupled system. The CMS database knows the content is published. But how does your front-end application know?
Right.
How does your search indexing service know? The CMS needs a mechanism to proactively broadcast state changes to your external infrastructure.
And enter the concept of webhooks. If you are deeply familiar with API architecture, you know webhooks. But let's explore how Contentstack implements them as the megaphone of the ecosystem.
Megaphone is a good word for it.
A webhook is a real-time HTTP callback triggered by specific predefined events within the platform.
Right. And the contrast here is between an event-driven architecture and a legacy polling architecture.
Let's compare those.
Historically, if your custom search index wanted to ensure it had the latest content, you had to write a script that sent an HTTP request to the CMS every 5 minutes asking for updates.
Which is a massive waste of network resources and database compute.
Totally. And it guaranteed your search index was always slightly out of date.
It's the technical equivalent of a child in the backseat constantly asking, are we there yet? Are we there yet?
Yes, exactly that. So a webhook completely inverts the paradigm. The external system doesn't ask, it simply listens.
Okay.
When a specific event occurs, perhaps an entry is created, an asset is deleted, or a critical update is published, Contentstack's infrastructure immediately constructs an HTTP POST request and fires it to a specific URL you've configured.
And that POST request isn't just a simple ping notifying you that something happened, right? The payload is incredibly dense.
Very dense.
Contentstack transmits a comprehensive JSON object containing the exact details of the event. It includes the unique identifier of the content type, the specific environment the event occurred in, the user hash of the individual who triggered the action, and a deeply nested entry object containing the complete data schema of the content itself.
And you can route that webhook payload to do all sorts of things. You can trigger an automated rebuild of your static Next.js frontend.
Very common use case.
You can route it directly to the API of Algolia or Elasticsearch, parsing the JSON payload to update your search records instantly. You can even route it to a serverless function that formats the data and pushes a notification to a specific Slack channel.
But testing these payloads locally can be incredibly frustrating because you typically have to spin up a local server, expose it to the internet via something like ingrok, and log the incoming request just to see the JSON structure.
Yeah, it's a hassle. But the Academy resources recommend using a free browser-based tool called webhook.site.
Oh, I love that tool.
It's brilliant. You generate a unique temporary URL on their platform. You paste that URL into your Contentstack webhook configuration, set the trigger event to publish, and then you publish a test entry in the CMS.
And then you flip back to the webhook.site browser tab and you watch the PST request populate in real time.
Exactly. You can analyze the exact HTTP headers Contentstack sends. You can expand the raw JSON payload and study the nested structure. Demystifying the exact shape of the data makes writing the backend logic to parse and utilize that data significantly faster.
For sure. It takes all the guesswork out of it.
If we connect this to the bigger picture, the way you can combine the strict state machines of workflows with the event-driven architecture of webhooks allows you to orchestrate massive automation pipelines.
Give us an example.
Consider architecting a global translation pipeline. You manage an enterprise application operating in 12 languages. Manual coordination is impossible.
Yeah, that would be a nightmare.
So instead, you define a specific workflow stage named Ready for Translation.
Okay, and you configure a custom webhook that is strictly scoped to that event. It only fires an HTTP POST when the state of an entry transitions specifically to Ready for Translation.
Exactly. And the webhook payload contains the core English JSON schema. You route that webhook directly to the API ingestion endpoint of an enterprise translation service like SmartLink.
Wow. So no emails, no exporting zip files, no manual API uploads. The simple act of the editor changing the drop-down state in the CMS automatically beams the raw data to the translation engine.
Yes. The external translation service ingests the data. Their AI or human translators perform the localization. And when the task is complete, their system leverages the content management API we discussed earlier.
Oh, bringing it full circle.
Yep. They authenticate via a management token, and they programmatically push the localized Spanish and French entries back into your Contentstack database. Furthermore, they use the CMA to mathematically update the workflow state of those new entries to approved.
Which in turn can trigger another webhook or satisfy a publishing rule, automating the final push to the live edge servers.
Exactly.
The entire global lifecycle executes flawlessly without a single internal employee moving a file. The infrastructure layer handles all the routing based on state changes.
It's automation at its finest.
But, and I have to point this out, standard webhooks have strict architectural limitations. Contentstack dictates the shape of the JSON payload, and it exclusively utilizes the HTTP POST method. What happens when you are integrating with a highly rigid legacy enterprise system, Like, what if your internal inventory management API strictly requires an HTTP PUT request to update a record, and it demands a highly specific, stripped-down JSON structure that doesn't match the massive payload Contentstack generates?
In a traditional architecture, this is where you're forced to build and host middleware.
Which nobody wants to do.
No one. You'd have to deploy a serverless function on AWS Lambda. That Lambda function receives the Contentstack webhook post, runs custom logic to extract the exact fields needed, transforms the JSON object into the legacy format, changes the request type to PUT, and then transmits the new payload to the legacy system.
And suddenly you are now responsible for the uptime, the security, and the maintenance of that middleware code.
It becomes technical debt instantly.
Yeah.
But Contentstack addressed this friction by introducing the HTTP Action Connector within their Automate capabilities.
Okay, let's explore that.
The HTTP Action Connector allows you to visually construct those nuanced custom API interactions directly within the Contentstack platform, completely bypassing the need to engineer and host custom middleware infrastructure.
Wait, I need to understand the fundamental difference here. How is an HTTP connector functionally different from a standard webhook? Because to me, both systems listen for an event and both systems transmit data to an external URL.
That's a great question. It hinges on HTTP methods and payload transformation.
Okay.
A webhook is a rigid broadcast. You get the whole payload in Contentstack's proprietary format via POST. The HTTP Action Connector, however, is highly mutable. It allows you to explicitly define the HTTP method. You can configure it to execute a post, a get, a put, a delete, or a patch request against the external API.
Ah, I see. So if the legacy database requires a PAT TCH request to modify a single column, the HTTP connector handles that natively.
Exactly. But the true power lies in the visual payload mapping.
Tell me more about that.
Well, say your Contentstack entry contains 50 distinct fields, author bios, rich text blocks, related articles, but your external accounting API only requires 2 fields, the product title and the CU price.
Right. It doesn't need the author bio.
Exactly. You use the HTTP connector UI to visually map just those 2 specific variables from your Contentstack schema into a custom JSON object. You dictate the exact key names the external API expects.
Oh, wow. So you are visually programming the JSON transformation layer. You get all the power of custom middleware routing without carrying the DevOps burden of maintaining a middleware server.
You nailed it. It's incredibly liberating for developers.
I can imagine. But, building custom webhooks and visually mapping HTTP connectors is incredibly powerful for bespoke internal systems. But constructing integrations from scratch requires deep API knowledge and time.
For sure.
If you need to integrate your headless CMS with an industry-standard platform like Shopify for e-commerce or Cloudinary for digital asset management, why build a custom HTTP connector when the integration architecture has likely already been solved?
Well, you shouldn't build it from scratch. You leverage the Contentstack marketplace.
Okay, the marketplace. This acts as a centralized app distribution platform. Conceptually, it mirrors the Apple App Store, but it is engineered specifically to extend the core operational capabilities of your Contentstack environment.
Yes, and this is the defining characteristic of modern composable architecture.
Right, composability is a huge buzzword right now.
It is, but it's grounded in reality. In the era of monolithic CMS platforms, you purchased one massive software suite. You were locked into their proprietary analytics engine, their native search indexing, and their built-in SEO tools.
Even if those tools were terrible.
Exactly. Even if a much better, dedicated SEO platform existed on the market, you couldn't easily rip out the monolith's native tool and plug the new one in.
A monolith forces you to accept a jack-of-all-trades, master-of-none infrastructure.
Perfectly said. A composable, headless approach rejects that entirely. The philosophy is, Contentstack will provide the absolute most resilient content database and API delivery network in the industry. But for everything else, search, localization, e-commerce, analytics, the platform makes it incredibly seamless to plug in the absolute best-of-breed tools available globally.
And the marketplace is the repository for those plug-and-play integrations.
Exactly.
And from what I understand, the extensions available in the marketplace aren't just back-end data connectors. They fundamentally alter the front-end user interface for your content authors.
Oh, absolutely. They can completely change the authoring experience.
You can install custom field types. Instead of a standard JSON string input, a developer can install a custom field that renders as an interactive color picker, or a dynamic YouTube widget that allows the author to search and embed videos directly from the CMS interface without touching an iframe code.
Which authors love. And the architecture also supports custom widgets. These can be dashboard widgets that pull live Google Analytics data onto the screen the moment a user authenticates.
Oh, that's convenient.
Yeah, or sidebar widgets that render contextual data alongside the specific entry being edited. You also have full-page apps that commandeer the entire Contentstack UI to provide a dedicated interface for managing complex third-party platforms, like a global translation dashboard, without forcing the user to open a new browser tab.
Here's where it gets really interesting. Consider the operational velocity this unlocks.
Okay, let's hear it.
Imagine your marketing team demands real-time SEO analysis. As they draft their copy, they want dynamic feedback on keyword density, readability scores, and meta description length.
A very common request.
Right. In a traditional engineering environment, the marketing director submits a ticket. The engineering team places it in the backlog, spends 3 weeks analyzing the API documentation of an SEO service, writes custom backend integration code, builds a custom React component for the CMS interface, and eventually deploys a brittle solution.
Which is just a massive drain on engineering resources.
Exactly. But with the composable architecture of the Contentstack marketplace, a user with the admin role navigates to the SEO category, selects an application provided by a leading platform, and initiates the installation.
Yep.
Within minutes, completely circumventing the engineering sprint cycle, the marketing team possesses a powerful real-time SEO analysis sidebar widget operating directly within their rich text editor.
It accelerates the business teams while fiercely protecting the engineering team's time, allowing developers to focus on architecting the core product rather than writing custom CMS integrations.
It's a win-win. And what if a company has proprietary enterprise needs?
Well, the architecture of the marketplace also accommodates that through the developer hub.
How does that work?
If your organization relies on a highly bespoke internal legacy database, your engineering team can code a custom React application designed to interface with it. They package that app, upload it to the developer hub, and deploy it as a private extension solely accessible to your authenticated Contentstack users.
So it's not on the public marketplace just for your team. It is the ultimate manifestation of modular composability. You plug in exactly what you need, you build what doesn't exist, and when a superior tool hits the market 2 years from now, you seamlessly decouple the old app and plug in the new one without rewriting your entire platform architecture.
Future-proofing at its best.
Absolutely. So we have explored an immense amount of architectural theory. We have detailed how to import massive JSON datasets via the CMA and CLI. We mapped the security infrastructure using custom roles and least privilege. We orchestrated state machines with workflows and publishing rules.
Oh, covered a lot of ground.
We really have. We broadcasted state changes using webhooks, transformed payloads with HTTP connectors, and extended the interface using marketplace apps. But if you are a developer logging into a headless CMS for the very first time, visualizing how all these decoupled API layers construct a unified web application can be daunting. How do you inspect a fully functioning architecture on day one?
You deploy a starter app.
Starter apps. These are pre-engineered, fully functional application code bases provided by Contentstack. They are available across the major modern front-end frameworks, Next.js, React, Angular, and Vue.js.
Right, and they serve as a vital reference architecture. Reading API documentation is necessary, but cloning a live, highly optimized repository engineered by the platform's own developers allows you to instantly analyze their intended design patterns.
You can see exactly how they handle routing, data fetching, and state management against the content delivery API.
Exactly. It takes it from abstract theory to concrete code.
Now, the documentation details 3 distinct methods for deploying a starter app. The first, and frankly the most technically impressive method, utilizes the automated CLI script. If you possess the organization owner role, you execute a single command in your local terminal.
And the automation sequence that command triggers is remarkable. Walk us through it. So the CLI authenticates with the Content Management API. It provisions a completely new stack, basically a new database instance. It programmatically injects all the necessary content-type JSON schemas. It populates the database with dozens of sample entries and high-resolution media assets.
Oh, so it gives you dummy data right out of the gate.
Yep, full dummy data. It configures the default publishing environments. It generates the required delivery tokens. Finally, it downloads the entire Next.js application repository to your local machine, automatically populating the environment file with the exact API keys and tokens it just generated.
That is wild.
Yeah, you go from an empty terminal to a fully populated database and a locally running server-side rendered React application in less than 5 minutes.
Okay, that's the automated way. You can also deploy a starter app via the marketplace, right?
You can. This method entirely bypasses the local code base. It is engineered for marketing directors or authors who want to evaluate the Contentstack UI, test the rich text editor, and experiment with the workflow state machine without ever opening a terminal or configuring Node.js.
Which is perfect for non-technical users. And the third method.
The third method is manual deployment. You utilize the CLI to manually push the JSON schema files to the stack, and you manually clone the GitHub repository and configure the environment variables.
Sounds tedious.
It is tedious, but manually executing the schema mapping forces you to deeply understand how the CLI structures and validates complex JSON payloads before transmitting them to the CMA. So it's a good learning exercise.
Fair point. Let's dissect the Next.js starter app specifically, as Next.js represents the current architectural standard for high-performance React applications. When you boot up that code base, the true educational value lies in analyzing how the front-end Next.js routing maps to the back-end content types, right?
Absolutely. The starter app operates as a masterclass in implementing design patterns with content types. It explicitly demonstrates how to architect front-end code to consume Contentstack's two most critical structural paradigms: modular blocks and global fields.
Let's analyze modular blocks first. In a monolithic CMS, a web page template is rigid. You have a title string, a feature image URL, and a massive HTML text area.
Very rigid.
If the marketing team wants to launch a landing page with a hero carousel, a 3-column feature grid, and a dynamic testimonial slider, they have to submit a ticket to the engineering team to hard code a completely new HTML template.
Which slows everything down.
Exactly. Modular blocks shatter that rigidity. A modular block is a dynamic JSON array field. It allows an author to select from a predefined library of schemas and stack them in any sequence.
Right. And from an engineering perspective, you build discrete, highly optimized React components: a hero banner component, a feature grid component, and a testimonial slider component.
Okay.
You define corresponding modular block schemas in Contentstack. When the author builds the page in the CMS, they are simply populating an array of JSON objects.
So when the Next.js application queries the content delivery API, the response payload contains that array.
Yes. And the starter app demonstrates the exact JavaScript logic required to iterate over that array.
How does it know which component to render?
The code inspects the internal content type UID key of each object in the array. If the key string is hero banner, the application dynamically mounts the hero banner component and passes the nested JSON data as props.
Got it.
If the next object's key is feature grid, it mounts the feature grid component. The author possesses infinite visual flexibility to construct landing pages, but they cannot break the front-end CSS or routing architecture because they are strictly providing structured data to the React layer.
It perfectly reconciles the tension between structured database design and flexible visual presentation. I love that.
It really does.
And global fields address the engineering principle of DRY. Don't repeat yourself.
Oh, this is a big one. If your application architecture requires 50 distinct content types, blog posts, author bios, product pages, event listings, every single one of those schemas requires SEO metadata.
Right.
They need a string for the meta title, a string for the meta description, and an asset reference for the open graph image. Hard-coding those exact same JSON keys into 50 different schemas creates massive technical debt.
Because if you ever need to append a new parameter, say a canonical URL string, you have to manually update 50 separate schemas, which is agonizing.
Agonizing and error-prone. A global field eliminates that debt entirely. You architect a single, centralized SEO core global field schema. You then inject that global field as a reference into all 50 content types.
So it's like a reusable block of schema.
Exactly. When you need to append the canonical URL parameter, you modify the single global field, and the structural update instantly propagates across your entire database architecture.
That is so clean. And the Next.js starter app repository explicitly demonstrates how to query that nested global field object and dynamically inject the variables into the head tags of your server-side rendered HTML document.
Yes, it shows you exactly how to wire it up.
So, as you transition from studying the starter app to architecting your own proprietary schemas, navigating the decoupled ecosystem requires robust maps and compasses. Let's detail the developer toolkit.
Contentstack invests heavily in developer enablement infrastructure. Your primary compass is the developer documentation portal.
What's in there?
It provides exhaustive, deeply indexed guides detailing the precise JSON payload requirements for every API endpoint, the available methods within every language SDK, and the specific limitations of complex GraphQL queries versus REST queries.
We previously analyzed the massive utility of the API's homepage and the Postman collections for isolating network logic. But I want to focus on the open source utilities Contentstack maintains on their GitHub repository, specifically the tools designed to handle the rich text editor, or RTE.
Ah, yes. This raises an important question regarding headless architectural theory.
Okay, what is it?
How do you properly store and transmit rich text?
Okay, yeah.
In a legacy, monolithic CMS, a rich text editor physically saves raw HTML strings directly into the SQL database. But a true headless API cannot assume the presentation layer is a web browser.
That's a great point. If your content is being queried by an Apple Watch, an audio-only voice assistant, or a digital billboard matrix, transmitting a payload full of div and span tags is functionally useless.
Exactly. The raw HTML payload would completely break the rendering logic of a non-browser platform.
Precisely why Contentstack's modern rich text editor fundamentally rejects storing HTML. Instead, it serializes the author's input into a highly structured, deeply nested JSON tree.
Right. It mathematically represents paragraphs as nodes, bold formatting as properties on text leaves, and embedded assets as distinct object references. The content is preserved in a mathematically pure, platform-agnostic state.
Which is architecturally brilliant, but it introduces massive friction for the front-end developer, doesn't it?
Oh, massive friction. Writing a recursive JavaScript function to traverse a deeply nested JSON tree and dynamically mount the correct React components for every bold tag, italicized phrase, and embedded image is incredibly tedious engineering work.
So how do we solve that?
To eliminate that friction, Contentstack open sources the JavaScript RTE parsing utils and the JSON RT serializer directly on GitHub.
Ah, so they provide the tools.
Exactly. You import these utility packages into your front-end codebase. When you fetch the nested JSON tree from the Content Delivery API, you simply pass the object into the parsing function. The utility automatically traverses the nodes and serializes the data into clean HTML strings or dynamic React components, depending on your framework's requirements.
You leverage their parsing algorithms rather than writing complex recursive loops from scratch. That saves so much time.
Days of work, easily.
The final critical tool in the toolkit addresses the fundamental trade-off of a headless architecture. When you completely decouple the backend database from the front-end application, the authors lose the ability to see what their content will look like before they execute the publish command.
Right. A monolithic CMS has native preview because it renders the HTML itself. A headless CMS just has JSON fields.
So how do you fix that?
Live Preview bridges that gap. Configuring Live Preview requires establishing a secure, real-time WebSocket connection between the Contentstack editing interface and your local or staging Next.js application.
Okay, so they're talking to each other constantly.
Exactly. When properly configured, as the author types a string into a field in the CMS, the platform transmits that partial string across the secure tunnel to the Next.js app, which re-renders the component instantly.
Wow.
The author views a side-by-side real-time rendering of the actual application UI, updating keystroke by keystroke, long before the payload is ever published to the edge servers.
It provides the strict, resilient API separation of a headless architecture, paired with the immediate visual feedback loop of a legacy monolith. That is the best of both worlds.
It really is.
Well, what an incredible, deep technical exploration we have navigated today.
We really went underground.
We did. We started deep in the engine room, detailing how to mathematically define schemas and import massive data payloads using the Content Management API, the CLI, and Postman. We constructed a security fortress around that data, establishing granular custom roles based on the principle of least privilege.
Crucial stuff.
We orchestrated complex state machines, governing the collaborative pipeline with workflows and strict publishing rules. We engineered the platform's routing capabilities, broadcasting JSON payloads via webhooks to trigger external systems, and utilizing HTTP connectors to execute highly specific PUT and PATE-TCH requests against rigid legacy APIs without deploying middleware.
We covered a lot of architecture.
And we embraced composability, expanding the interface with marketplace apps. And finally, we visualized the entire ecosystem operating in perfect concert by dissecting the server-side logic of the Next.js starter app.
Mastering this ecosystem fundamentally elevates how you operate as an engineer. You evolve from simply writing front-end component code to architecting highly resilient, scalable, and self-governing digital infrastructure.
It fundamentally shifts your perspective.
Yeah.
Which brings me to a final thought for you, the listener, to mull over as you close your IDE or finish your commute.
Oh, I'm ready.
If a headless CMS completely abstracts the content from the presentation layer, and tools like webhooks and HTTP connectors completely abstract the business logic away from your monolithic backend server, and the app marketplace abstracts complex third-party integrations entirely out of your codebase?
Where we're going.
Exactly. Are we rapidly moving toward an architectural future where the front-end application as we conceptualize it today, the massive React repositories we spend months engineering, becomes entirely ephemeral? If the content database, the routing logic, and the integrations are all autonomous managed services communicating via standardized JSON, the front end is no longer an application. It is simply a temporary localized projection of an incredibly intelligent, self-managing data web.
That is a wild thought to leave on.
When the subterranean infrastructure becomes this powerful, the skyline can change its entire shape in a matter of milliseconds. Keep architecting, keep questioning the monolith, and keep diving deep.